Here's our example for a two-way table. The Pew Research Center asked a random sample of 2024 adult cell phone users from the United States which type of cell phone they own, an iPhone, an Android, or other, including a non-smartphone. Here are the results broken down by age category. By the way, age is a categorical variable here because we have grouped them into age brackets. So that would be a categorical variable. Type of phone is a categorical variable as well. So this table is called a two-way table. Why do you guys think it's called a two-way table?
There's two different individuals that there's.
Perfect, right? It's because we can read it two different ways based on which variable we want to look at. We can read it based on age and we can read it based on type of phone. So two-way table is called two-way table because there are two categorical variables that we can base our calculations on. Yay! There are two categorical variables that we can base our calculations on. We can base our calculations on age, or we can base them on what type of phone they have. All right, so there are two different categorical variables. So here we go. Time to do some math, kids. Yay! What percent of the sample are 18 to 34, 35 to 54, or 55 plus? What percent of the sample is 18 to 34-year-old, 35 to 54, or 55 plus?
For which 18 to 34 is 25.5%.
Okay, so the percent of the sample that is 18 to 34, well, if I look at, I'm reading this based on age this way, right? So 18 to 34, what percent is 18 to 34? That would be 517 out of 2024 total, right? So 517 out of 2024. And what is that as a percent? This is why your calculator is going to come in handy. What is 517 over 2024 as a percent?
25.5.
25.5%. Very good. And then we're going to do 35 to 54. So if we look at 35 to 54, that's going to be 637 out of 2024. And what is 637 over 2024 as a percent?
31.5.
31.5%. Very good. And finally, we'll look at 55 plus. 55 plus. That's going to be 870 out of 2024. That should be the rest of them. 870 out of 2024 is? 43%. Very good. And what should those add up to? They should add up to 100%. Very good. Do they add up to 100%?
Yes.
Looks pretty good to me. Perfect. All right, now we're going to do what proportion of the sample own an iPhone, an Android, and other. So I know that yesterday when we talked about proportion, we said it's a fraction, a decimal, or a percent. Generally speaking, though, in stats, if we want it in a percentage, we'll specifically ask for it in a percentage. If we say proportion, we generally mean a decimal. Okay, so that's just kind of the language that we use. So we're going to try to get used to that. So when you guys see the word proportion, try to give me a decimal, and if you see percent, give me the percent. I'm not saying that if I ask for a proportion and you give me a percent that you'll get it wrong necessarily. I'm just saying that's the kind of language we prefer and the way we prefer it to come across. So with that being said, let's get the proportion, the decimal for each of these types of phone. So iPhone now, we're going to go on the rows now, right? So we're going to look at the rows. So for iPhone would be 467 out of 2024. And what is 467 out of 2024 as a proportion or a decimal?
0.230. 0.2307.
Very good. And I love, thank you very much. Is it Katie? Cami? Ava. Katie's the one that's absent next to you. I'm sorry, Ava. Thank you, Ava. Ava gave me 4 decimal places, which is actually preferred. That 4 decimal places is the preference. Very good, Ava. All right, cool. And then our next one, Android.
0.2485.
503 over 2024. I'm sorry, say that again.
0.2485.
2485. Perfect. You guys, you better be thankful Ava's in this class because she is giving you all the answers. All right. And then for other here, we've got 1054 over 2024, which is 5207. Very nice. If I added all those proportions up, what should I get? I should get 1. Now, with this whole decimal thing, you might get 0.9999999. That's fine. That's just round off error. That's not that big of a deal. It's not going to kill you. Yes.
It was 0.5208.
Oh, yay. See, there we go. Perfect. There we go. All good? How we feeling? All right, so I want you guys to know that what we just found here, these numbers right here, these percentages for the ages, and then these decimals or proportions for these cell phone types. These are called marginal relative frequencies, I think. Is that what it says on the next thing? Yeah. Or marginal distribution. I don't remember what's going on. I don't use these words very often. I know, I'm just the teacher. It's fine. These are called marginal relative frequencies. There it is. Marginal relative frequencies. Why do you guys think this would be called a marginal relative frequency for age and a marginal relative frequency for phone type? Why might they be called marginal relative frequencies? Notice where every number came from. 517 out of 2024. 637 out of 870. Or 637 out of 2024. 870 out of 2024. 467 out of 2024. 503 out of 2024. 1054 out of 2024. Where did it come from? The margins, right? Where the totals are. So each of these are called marginal relative frequency for age because it is the total over the total for the age categories. This is called the marginal relative frequency for type of phone because it was the total out of the total for the type of phone. And so it came out of the margins. Okay? Make sense? Ish? So these are called marginal relative frequencies because the values come from the table's margins, which have the totals for each category. So it's going to always be a total over the entire table total anytime you're doing a marginal relative frequency. All right. Now let's look at the next question very carefully. What percent of the 18 to 34-year-olds also own an iPhone? How would you find that answer? What percent of 18 to 34-year-olds also own an iPhone? So let's look at that table real quick again. What percent of 18 to 34-year-olds also own an iPhone? How do you guys think you're going to find this answer?
169 over 2024.
Do you guys agree?
No, over 517. Over 517.
Okay. So it says what percent of the 18 to 34-year-olds? So I am zooming in on the 18 to 34-year-olds. So what we're talking about here is of the 18 to 34-year-olds, these guys don't matter for this question. Of the 18 to 34-year-olds, what percent also own an iPhone? You would just do 169 out of 517. Very good, very good. Perfect. 169 out of 517. All right, so. She said real quick, so probably not. Also own an iPhone. So 169 out of 517. Whoops. Oh, here, Joshua. Just take that with you. Thanks. No, just walk. All right, what percent? What is 169 over 517 as a percent?
32.7.
32.7. Okay, cool. Now, Android. Again, what percent of 18 to 34-year-olds also own an Android?
41.4%.
So this is going to be 214 out of 517, which is, I'm sorry, one more time?
41.4%.
41.4%. I forgot my little percent mark there. Okay, cool. And then other, what percent of 18 to 34-year-olds also own other? So that would be 134 out of 517, which is
25.9%.
25.9%. Perfect. All right, does everybody see why we were using 517 on the bottom instead of the 2024?
Yeah.
Okay, because it was of the 18 to 34-year-olds. Perfect. All right, what proportion? Oh, check this out. What proportion of Android users are 18 to 34-year-olds? What is the fraction you're going to use to get this answer?
214 over 503.
214 out of 503. Why is the 503 on the bottom?
Because it's the total of Android users.
That's the Android user total. You got it. All right, and we are doing proportion this time, so we're back to our 4 decimal places. What is 214 out of 503?
0.4254.
4254. Perfect. And of Android users, 35 to 54-year-olds, that would be 189 out of 503. And that is, as a decimal,
0.3757.
3757. And last but certainly not least, our older generation that likes to use their Androids, we've got 100 out of 503. And that is
0.1988.
1988. Okay, perfection. Ladies and gentlemen, these are known as conditional relative frequencies. Any ideas why these might be called conditional relative frequencies? Conditional relative frequencies. Very good. I'm finding these values based on a specific condition of being in one of the particular categories, okay? So the values are found with a condition of being a part of a specific category. And by the way, that specific category that is the condition, that specific category's total will be on the bottom of every one of the fractions. The condition here was 18 to 34-year-olds, and there were 517 18 to 34-year-olds. The condition here was Android users, and 503 was the Android user total. So whatever the condition is, that's going to be the total that's on the bottom for these guys. Does this make sense to you? All right, perfect. I want you to know that there are actually 4 other conditional relative frequencies that we could have found. We could have found the percent of 35 to 54-year-olds that have an iPhone, Android, other, and then the percent of 55 plus that have an iPhone, Android, and other. So we would have done the same thing with each of those columns. we could have found the proportion of iPhone users that were these ages, and then the proportion of other that were these ages. So there's actually 4 more conditional relative frequency amounts that we could have found. All good? Feeling great? I love it. And in fact, here they are. Here they are. This is the conditional distribution based on age group. This is the conditional distribution based on age group. So, we've got our 18 to 39-year-olds, and we've got each of the conditional relative frequencies for each age group. There they are. Okay? So, we can take that and turn that into something called a segmented bar graph. Have you guys ever heard of a segmented bar graph before? Yeah. Probably you've seen it or used it. Here's what it looks like. So what we do is we basically take the data for each of the conditional relative frequencies, each of the categories, and we turn it into a stacked bar chart, basically. All right, so we took those 18 to 34-year-olds, 32.7% used an iPhone, so we made that bar, that first bar on the bottom here, this blue one, we made that 32.7% high. Then we stacked on top of that 41.4% of Android users, and then we stacked on top of that 25.9% for other. Okay? Then we made our next age category, 35 to 54, and we stacked iPhone on the bottom, so 26.8 right here. Then we stacked the Android on top, and then the other, and then 55 plus, we did same thing. The order, you have to keep it in the same order. It doesn't matter what order you go in, honestly, but you do have to keep it in the same order for each category: iPhone, Android, other. All right, tell me a little bit about what you guys notice about this segmented bar graph. What do you notice about these bars, these segmented bars? Very good. It starts at 0%. That's awesome. Do these look the same? Like, do each of these look the same? No, why not? Well, there must be something going on here. There must be a difference, right? Depending on what age group you're in, must mean that there's a difference in the type of cell phone you might have, right? If I know that I have picked a 55 plus person, what type of cell phone am I going to guess they have? Other, right? If I pick an 18 to 34-year-old, what type of phone am I going to guess they have? Probably an Android or maybe an iPhone, right? But I'm not going to probably guess other, right? These look different, okay? So our segmented bar charts can help us identify if there's an association or something going on here, okay? So some important things about segmented bar charts. The y-axis goes from 0% to 100% every time. Every segmented bar chart goes from 0% to 100%. And each bar must take up 100%. Some people forget to do that, and they make one of them, they like forget a category in one of them. So just make sure if you're doing a segmented bar chart, you have to make sure that each bar goes all the way to the 100% mark. And then each category is stacked in same order. Again, it doesn't truly matter what order you stack them in as long as they're the same for all of the bars. So iPhone, Android, other, that's fine. Okay, so when is there an association? Meaning, an association is if I know one variable, it can help me predict the other. If I know one variable, it can help me predict the other. So, when is there an association between two categorical variables. When knowing one variable helps to predict the other variable, an association exists. Okay. If I look at the bars and they look different, that means there's something making them look different. There's a reason they look different. That reason is because something is associated. There's one variable is helping me tell something about another variable. Thank you. One variable is helping me to determine something about the other variable. If all the bars look exactly the same, here's an example. Let's say our chart looked like this. Let's say this was what our bar chart looked like, right? Would knowing your age help me determine anything about your cell phone? No. Every age group would have the same % chance of having a certain type of cell phone, right? Whether you're in this first category or the last category, it would be the same % chance of having an iPhone, Android, or other. So it wouldn't help me predict anything. This right here would be no association. This is no association because knowing one variable doesn't change my prediction. So that's not helpful for predicting anything. If the bars look different, when the bars look different, it is due to an association. When the bars look different, it is due to some sort of an association. There's some reason that they look different, and it's because one variable is affecting the other possibly. They're at least associated in some way. So, here's the question. Is there an association between age and cell phone type? Yes, there is. Knowing age can help predict cell phone type. Specifically, knowing if you're an older person helps us to predict that you probably have an other or non-smartphone. And being in the younger age group helps us predict that you probably have a smartphone. Okay, last question here on this page. Let's say there is an association. Does that mean that one of them is causing the other to happen? Does being a certain age cause you to have a certain kind of phone? No. So many of you may have heard this statement before. Correlation does not imply causation. Have you guys ever heard that before?
Yeah.
Sort of, maybe-ish, maybe once in your life? So that is similar to an associated. Correlation and association are kind of the same phrase or term. So just because an association exists doesn't mean that one thing is causing the other. Okay? Did you know that the amount of sleep you get is associated with your grades? Did you know that? But does that mean that you just have to sleep more to get better grades? No. Okay, so correlation doesn't mean it's causing it. It just means there's something there, right? So, does association imply causation? No, and triple no. I'm going to show you some examples here in a second that are going to make you wonder about your life. It's going to be great. Yes. All right. Last page for today. Mosaic plots. Yellowstone National Park staff surveyed a random sample of 1,526 winter visitors to the park. They asked each person whether he or she belonged to an environmental club like the Sierra Club. Sounds so fancy. Respondents were also asked whether they owned, rented, or had never used a snowmobile. Here is the two-way table summarizing the results. A two-way table, two categorical variables. Environmental club, yes or no. Snowmobile use, never used, snowmobile renter, or snowmobile owner. Here's all the data. We took that table, we turned it into a conditional distribution for based on environmental club usage. So we found each of these percentages for no. We found each of the percentages for yes. We turned it into a regular bar chart. Then we stacked the bars in the same order, turned it into a segmented bar chart. Do those bars look different? They do. Is there an association? There is, okay? If I know that somebody is a part of the environmental club, what am I probably going to think about their snowmobile usage? That they have never used one, okay? If I think that if they're not a part of the environmental club, then I'm probably going to think that they have a better chance of having either rented or owned one. Does that mean that if I join the environmental club that I can never use a snowmobile? No. There's not a causation. There's just something going on here. Okay, there's an association of some sort. And finally, this is a mosaic plot. What's the difference between the segmented bar chart and the mosaic plot?
The mosaic plot takes into account like total number of people, so the people that said no, there was more, so it has a bigger square.
Good. So it's the width, right? So the width of the no got bigger for some reason. So we need to think about why is that? So we look at our totals here for no. There were 1,221 people in the survey that said no. There were only 305 that said yes. So a mosaic plot, which you can see that right here, it says here, the mosaic plot takes into consideration the number of people, all right? A mosaic plot is going to take into consideration the number of people. So the reason that this is wider here is the total was 1,221. This total was 305. About how much is 1221 in relation to 305? About how much bigger is that ish? About 4 times ish. So guess what? This is about 4 times as wide. Okay? So it is proportionately wide. So if it's only twice as wide, then my mosaic plot would only be twice as wide for whatever category that would be. Does that make sense? So your mosaic plot is proportionately wide based on your sample size. What questions do you guys have about this? All right, very cool. Yay! Two-way tables, mosaic plots, associations. Holy cow, we learned a lot today.